Today's lesson is going to focus on the concept of enthalpy. Our last few lessons have focused a lot on heat and calculating heat and talking about heat and the transfer of energy. We're still talking about heat when we talk about enthalpy. The only difference now is that when we're talking about the heat change, we are now focusing on the system. In our previous lessons, particularly when we were solving for Q or using this formula, Q equals mc delta T, we were calculating the heat of the surroundings. And we understand that the heat of the surroundings is affected by the system. But now we're focusing and we're going to be talking and calculating heat change related to the system. And when we do this, we now use this term of enthalpy. Okay, so when you say the word enthalpy to other chemists, we know that we're talking about the heat that is coming right off of the system or being given to the system, depending if it's endothermic or exothermic. Enthalpy accounts for the internal energy of a system. Heat does not. Enthalpy is measured in joules or kilojoules because, again, heat is a transfer of energy. And enthalpy is still hard to measure. Okay, this is now we're talking about this, overall energy associated with the system. And it includes a variety of things. It includes the energy of the physical state. Okay, so that's dealing with the potential energy of your solid, liquid, or gas. It also can talk there about the kinetic energy, right, of your solid, liquid, or gas and relate that. It also is dealing with potential energy, so the energy stored in the bonds, and then also energy stored in the nucleus. So it does account for all these different aspects of the atom and, the way that the atoms are existing and interacting within the system itself. So what we do is just like with heat, we measure the change in enthalpy. There will be times where we will use standard enthalpy values. Okay, so standard enthalpy values are values that might be given to us based on certain chemical reactions. And when they are given to us, they are usually carried out, or those enthalpy values are obtained at SATP conditions. So you might recall that stands for standard ambient temperature and pressure. So 25 degrees C, 100 kPa. And that's just a little side note that's what those values tend to be measured at. And then enthalpy values can be reported and calculated for all kinds of processes. Okay, so we know that there's physical, chemical, nuclear changes or processes. But here in our course, we're going to look mostly at physical or chemical. And then we just try to be a bit more specific. So here's our symbol for enthalpy, right? Delta H. So capital H is standing for enthalpy now. And then if you see a little, word written as a subscript, so that doesn't say comb, like what you would comb your hair with. That's the short form for combustion. Or maybe we're calculating the enthalpy of a neutralization reaction. Or maybe we're calculating the enthalpy of solution. So we're taking some solid and we're dissolving it in water. And we know that that physical change would either be exothermic or endothermic. And we can calculate that. So oftentimes you're going to see little words written beyond the delta H symbol. And that's just trying to be more specific as to what kind of change you're talking about. Because we know that all physical or chemical or nuclear changes are either endothermic or exothermic, we now start to write something called a thermochemical equation. And what these thermochemical equations are is this is the reaction, right, of the system, either the physical, chemical, or nuclear change. And we write it as a balanced chemical equation, just like we would ordinarily. The difference is now we're going to enter in an energy value, either on the reactant side or on the product side. So we're going to incorporate this enthalpy value. And sometimes we write it in the reaction, sometimes we separate it. So here is an example of an exothermic reaction. Remember, these are reactions where the system is releasing energy. And so you'll notice here that it's releasing 285.8 kilojoules of energy on the product side. That's telling me it's an exothermic reaction. If we don't want to write it in as part of the actual reaction, then the other option that we have, and this tends to be used a bit more common, okay, but you'll see both. We take the energy term out of the reaction and we write it separately on the side. So here you'll notice it just says enthalpy of a reaction. Okay, so sometimes we're a bit more specific. Sometimes if we can't really classify a reaction, we just write RXN as the short form. And the value here, you're going to notice this negative sign. This is very, 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 very important. Okay, so like make a note of this. When you see an enthalpy value that's negative, that negative sign is indicating that that energy is leaving the system. If it's leaving the system, it is on the product side, it is exothermic. Okay, so the system releases energy. And why it does this is that more energy is released by creating the bonds of our product than was needed to break the bonds of our reactants. And as a result, the change in enthalpy is a negative value. So let's look at endothermic reactions as well. So with endothermic reactions, right, the term endo kind of implies entering, okay? So there's energy or heat entering the system. You're going to see this either on the reactant side, or if we pull the energy value out of the thermochemical equation and we write it off to the side, you're going to see it with a positive sign. And that positive sign is to imply that that energy is being added into the system as part of the reactants. This is why it's endothermic. So now my system is going to absorb energy if it's endothermic. And note this, more energy is now needed to break the bonds, okay, of my reactants than is needed to, or than is released by creating the bonds of our new products. And as a result, the change in enthalpy is positive. So this is just a little overview of enthalpy. Again, we're going to be focusing on the system, not the surroundings. And there's different ways that we can represent enthalpy depending on whether we have exo or endothermic reactions.